Okay, stat students, we're going to talk about slope and y-intercept in terms of uh, predicted line or prediction or line of best fit. Okay, we call that least square regression line in the stats world. So if we look at this example here, where we're talking about McDonald's salads, we've got the sodium and fat content in these salads. Okay. And I'm going to jump down to number 11 here when we think about slope and y-intercept. Okay, you can kind of think of like looking at this as a positive slope, but we want to now like bring in some real life context to this problem and understand that the line that we have here is not the actual salads, right? Those are the points. The line is a prediction going off of the trend that we're noticing with those points. Okay, that's how that plays out. So we have to think about how to write that out when we talk about the actual equation of the line, because it's not an actual outcome, it's a prediction. So there's the equation of the line. And we say this y hat here because that is a prediction, it's a predicted line. Because of it not being a line that connects every single actual data point. Okay, so when I talk about slope, there's a couple things that you want to make sure that you get. Well, first, you want to learn how to get what context we're dealing with. Okay, so let's identify the context and which is my x, my explanatory, and which is my y. So when we look at the problem, it actually tells us where y hat is the fat content. So if I'm thinking about fat content, that's my y, and x is the sodium amount. Okay, so that's my x. So that's the first thing. We want to be able to identify what we're looking at. If we don't see that in the problem, we can look at the graph as well, right? So sodium for x, fat for y. So that's important because when we talk about slope, right, we can see that it's positive, right? And we actually can see the value. And notice the value here is next to your x. It's not y equals mx plus b, it's over here. So this is my slope, still next to x, right? Because that's what it's changing, all right? So this is my slope. It is positive, okay? And now what do I want to say about it? Well, this number, this 0.21, is an increase for every time that I move over on my x, right? So as x increases, y also increases by this amount. But there's some specifics that we need, all right? And I'll show them to you here, okay? This is our framework. So if I'm talking about slope, we're going to use this sentence here, all right? When we have that number, that 0. Let me go back, that 0.021, that number happens for each unit increase on my x. So we want to talk about it for like each time x goes up 1 unit. So for this one, we would write it out just with that sentence there with each additional what? What is my context for x? We already identified that, each additional sodium. And you can put sodium amount, that's fine, but we're going to just stop it there, okay? So that's the first part. That was our x context. Now we talk about it as a predicted increase, right? So we have to use that word predicted. So we say the predicted y, right? Our y context is fat, the predicted fat content. This being positive means that we are increasing, right? Each time. So we saw that increases by how much? Well, there's the number. So you can use this framework for any context you have. You can even, in this set of problems, cut and paste this, right? And then just fill in the blanks from there. The sodium is our X, fat content is our Y. We're increasing because the slope is positive, and what's that number for slope? 0.021. So that's slope, all right? Now let's go to y-intercept, all right? And we'll put that sentence down here. So we see where the y-intercept there, it's by itself, right? It's the constant. That's our y-intercept. Okay. And then where does that happen? The y-intercept always happens when x is what? 0. So when x is 0, that's where the y is going to be in our prediction line. Okay, so we'll start off with that sentence, right? This is the y-intercept sentence. When x is 0. But what is our x in this context? Sodium. When sodium is 0. Okay, so that's the first part. This y is still a prediction. It's not an actual outcome. So we say the predicted y, but not y. In this case, what is it? Y is fat content. So we say the predicted fat content is what number? Is negative 0.672. Okay? So those are the fill in the blanks for y-intercept. All right? Now, can you have a piece of food that has negative fat content? No, that's not possible, right? But that's not what the question was asking. It just said interpret that number within the equation. So you can think about in real life, you might have a question, does it even make sense? Does this y-intercept make sense in real life? No, because you cannot have a salad with negative fat. But in this case, it just asked to interpret, so we write that sentence. Okay?